How's it going, guys? I think today we're going to try to begin the disassembly on the Yokogawa, but first we're going to do some function testing. And I've mentioned function testing before on the 80/20s, things like that. I figured I'd just take this chance to kind of go into it a little bit more on exactly what that means as far as when I'm doing it for multimeter repairs. Um, right now I've got the equipment that I'm going to use warming up. And some of the stuff that I use is, in this particular case, I'll use the 87.5 because I don't have a better one at the moment. I have a Keithley 192 that actually needs to be sent off for calibration, so I don't want to use it because I don't trust it, but I do trust the 87.5. And you always want to try to use a reference because I don't use voltage standards, or I don't have any standards of anything really. So I always use a good known meter as a reference, and whenever you're using that reference, you always want it to at least be equal to whatever you're trying to verify. The 87 actually, I believe, is a little bit worse than the Yokogawa, but in this case it'll be okay because we're not trying to do any certification or calibration, which that actually brings up another good point, is that there's basically three tiers of what could kind of fall under the umbrella of calibration. There's function testing, which is what we're going to try to get to today. There's certification, verification, kind of, they fall into the same thing. And then there is the actual full-blown calibration. For function testing, that's a very general, rough. You're not trying to worry about any kind of measurements or anything like that. You're actually just trying to see if the meter works. If you're buying a meter in person, you're going to want to do some function testing. First of all, you want to make sure it powers on. If it doesn't power on, you want to hopefully have an idea of why it doesn't want to power on, because this is what you're going to use to determine the viability of whether or not this meter is worth getting and whether or not it can be repaired. So it's really hard. You can't do that kind of things if you're getting meters like this online, but if you're doing it in person, you do want to do a function test. Really generally what I'll do is I'll check power up. I'll try to read a voltage. If you don't have any kind of voltage source other than the mains in the wall, I'll tend to shy away from that on an unknown meter. But even just a 9-volt battery, something like that, you're mainly not really looking for a really accurate reading at this point. You really just want to see a change. You want to see that when you put the probes on a battery, that the voltage does go up a little bit, that the meter is trying to do something, because you're just trying to determine that the chipset in there is really still ready to go, because that, at least for me, often will determine if a meter is a total loss or not. Stepping up a little bit from there is whenever you get into the kind of verifying measurements. This is where you want to see if your meter is accurate or not. This is where having an accurate reference is absolutely necessary, because you want to know that what this meter is telling you is true. Now, realize that we are not actually going to have any kind of traceable certification on this. You're mostly going to just use it basically to say that I'm using this meter and I know it's good because I've compared it to another known meter. If you're buying a meter and they claim that they've verified measurements on it, I would request pictures. If they can't do pictures, a table of offsets, which would basically be, it could even be a written sheet of paper, something like this one here. This is what I use on my decade resistance box, but it's basically just saying that this is what I read. This is what I was hoping to see, just so you can see how far off things are. It's nothing official. It's just an idea. Moving up from the verifications is the full-blown calibration. Now, to me, calibration is used kind of as a loose term, because there are actually two different categories of calibration. Both result in a accurate calibrated meter for the most part, but on the first part of it, you'll have as found, as is, as left, which basically means that they tested the meter against standards, and these are not just yeah, we know that this is 1.5 volts. This is a traceable standard. In the US, most oftentimes that's going to be traceable to NIST, which is the National Institute of Standards and Technology, which is actually a part of the US Department of Commerce. And they'll calibrate these meters to be traceable to NIST. That means that from NIST standards, you can follow a line of devices down to the device that they use to calibrate your meter. And this is whenever you get into official. This is when it gets expensive. If you're calibrating multimeters, it's very, very expensive. The equipment is expensive, and to actually get it done officially and have that traceability is very expensive. But in the end, you will get a NIST traceable certificate saying that this meter is absolutely as accurate as they say it is. But I think I've gotten a little bit off topic here. Going back to the as found, as is, as left. Basically, all they're doing is checking it to the standards, and if the meter checks out to be within spec that the service manual will state it needs to be at, they don't have to touch anything on this meter. They'll give you maybe a table of offsets and a certificate of calibration to show that this meter was in fact calibrated. It'll have a date calibrated, and it'll also have a due date, which is normally annually. It really depends on your use, what determines if you're going to do it annually or more often or less often. Some meters you may only have calibrated once every 5 years. It just all depends on what you're using it for and whether or not you need it to be calibrated yearly or not. The second form of calibration is where they're actually going to go in and adjust it. To me, this is whenever you really get into the calibration of things. It's because you check this meter, like the Keithley 192, and it's off. It's out of spec. You have to go in and adjust that and get it accurate. Maybe not you, maybe the service company. Some people do their own in-house calibrations. I don't really recommend it. I recommend getting third-party calibrations if required, because if you ever have any audits or anything like that, in-house calibrations are often suspect by the... So that's pretty much it on the notes on verification, calibration, things like that. As far as what I'm going to do today for verifying, I have a voltage reference source. It's a very old Heath built. What was his name on YouTube? MJ Lorton. If you check out his channel, he's done a video on this before. It's a good voltage reference. It's only specified to 1% accuracy, which is absolutely horrible for modern meters. But it does provide a very good, stable voltage that I can dial in pretty precisely using the 87 as a reference just to see if we match up. So we'll be using that as our reference today. To power up this meter, if you have a good fresh set of batteries and The meter can actually take batteries. This meter cannot. If you saw my previous video, you'll know that the battery compartment is actually corroded and missing on this meter. So to test it, I'm going to use a variable power supply, which will also allow me to monitor my amp draw in case something in there is shorted. If it's drawing way too much power, then I know that I'll have a serious problem inside of it. And it'll also give me a stable known input voltage so that I know that that's not affecting my readings, because a low battery can affect multimeter readings. So we're going to kind of skirt around that by using a power supply. As far as leads, I'm going to use some stackable banana jack leads. These are good quality ones. Don't try to use little cheesy cheap ones. But for function testing, I don't recommend using leads that came with multimeters if you purchased a multimeter, because if the leads have a problem, then you're going to see that problem in the function test, but you're going to go from function testing to troubleshooting really quickly. So it's best to just eliminate that from the get-go, use your own leads that are known goods, and it's just one less variable in the equation. Because that's what function testing is all about, is getting down to the bare bones of the meter to know whether or not it's workable to repair, whether or not it's worth buying, anything like that. And also, anytime you're going to try to sell a meter, do some sort of documented, at least function testing. Verification is awesome whenever you're trying to sell a meter. Unless you're trying to sell a broken one, then at least try to state what you believe the problem is. That's a big turnoff to a lot of people whenever they're looking at these meters online, is that there's almost no information on them to know whether or not to help them judge if it's going to be worth purchasing. So, alright, so I realized I didn't have a very good closing for this video, but coincidentally today, the Keithley got delivered with a fresh Certificate of Calibration. We'll go through this just to show the specifics of what I was talking about, most of all for the table of offsets. And as you can see, I knew that this meter was out of specs horribly on a couple of the ranges, and it actually turned out it was a little bit worse than I thought. But we'll go through it and we'll show exactly what everything means on here. And I'm sorry, but I'm going to have to flip it around because I can't read upside down very well. So let's start off by working our way down. At the top you can see they call this the calibration data sheet, which I call it table of offsets. This is probably the more proper term for it. And here you can see the as found, as left, and test result. You can see that my meter failed, but as left, it passed. So it's very important that this shows that at first it did fail, but they were able to adjust it in the spec. So that tells us that the meter wasn't broken, it had just drifted out. And then you see here it starts off each range with the 0.2 volt, and they test it at 0.09 volts. And they don't go decimal places way out to show the 6.5 digits, because they're using a voltage standard that is going to be absolute 0.1900000 past the 6.5 digit resolution of the Keithley. They could probably go to 8.5 digit and then they would start getting some drift, but 6.5 digits is going to be dead on 0.19 volts. So they just saved that. But as you can see, we failed because we were quite a bit out for the accuracy rating that the reading was supposed to be. And they adjusted it. They actually only adjusted it about 0.0015 5 and a little bit volts. So it sounds really, really small, but whenever you're getting into these 6.5 digit resolutions, really, really small can become really, really big very quickly. 2 volts, 2 volt range was fine. 20 volt range, this is the range that I knew was very badly off. And as you can see, at 10 volts, it was reading 10.08. That's bad for a 3.5 digit meter. And I have a 6.5 digit meter that was reading that roughly. But they brought it right in the spec. I mean, dead on 10 volts. That is awesome. And then I wasn't really concerned about this one. I had no way to really test it. But the 1200 volt range was actually off. And it wasn't off by too much, by 2 volts. Give or take. I mean, if you're dealing with 1,000 volts, you know, that's generally not going to be something you specifically need dead on accurate. But they did actually get it very, very close. The AC voltage was all fine, which doesn't really surprise me because in the 192, the AC voltage is actually optional, and mine just so happens to have that option installed. But because it is a separate module, then the DC accuracy and the AC accuracy are almost completely independent of each other. But as you can see, they started off with 20 kilohertz, then they went up to 100 kilohertz, 30 kilohertz, 20 hertz, and 50 hertz. Generally what we'll be using is probably going to be the 50 hertz rough measurement. It'll actually probably be closer to 60 hertz because the main thing that I measure with AC voltages is mains voltage. Here we have an AC plus DC mode test. I'm really not positive why this is on here. I think just because it's included in their data sheet. Because the Keithley doesn't have AC plus DC as far as I know. I've been through the manual on it. I haven't seen anything mention it. But maybe they're just measuring a rectified voltage or something along those lines. This is important for something like the Tektronix, the DMM870. It does have AC plus DC voltage. I believe that the 87.5 is also capable of that. There's several meters out there that can do it. But the Keithley in particular, 192, I don't believe can actually do it. The resistance ranges, I had assumed the resistance ranges would be fine, and for the most part I was right, except for, once again, this 20,000 ohms range, which is the same range, incidentally, that was out on the DC that I knew of. So that's not totally unexpected, but it is actually kind of strange also that when it was shorted, it didn't show anything. But whenever they did actually put the resistance standard on it, it showed that it was out. And not by very much. Just a, what would that be? 0.01-ish ohms. But they got it dead on right now. So if I put a high precision 19 kilo ohm resistor on there, I should see that precise 19 volts. Now if you look along these two columns here, these are more or less just the references of to show you if you're below or above or within spec. And you can see here accepted limits, and then there's a low accepted limit and a high accepted limit. And as long as you're in between those two numbers, your meter is within spec. On the front cover, all this is just other stuff. I don't even know if I'm supposed to show y'all that. I'll have to get some permissions for that. But it shows you condition in, whenever they got it in, it was out of tolerance. Condition out, it was adjusted. The action was they checked the accessories, they cleaned it, calibrated, and certified it. The procedure used was the manufacturer's procedure. I actually emailed Tektronix, who owns Keithley now, and they sent me right away, no questions asked, the entire manual on this machine, including the calibration procedure. This here is the equipment that they use to calibrate it. It's a Fluke 552A SC600. I'm not sure what the SC600 designation is for, but it is a multimeter calibrator. I believe that this is their internal serial number, and then this date is the date that it's due for its next calibration. So they do actually even calibrate the calibrators themselves. Alright, so I've got the Keithley and the 87 on the bench. This is just to kind of show a little comparison about how accurate these meters actually are. You know, I've used the 87 in a lot of videos for function testing and things like that, and it's actually not calibrated. I just have really good confidence in the measurements. But I mean, if you look at it, it's well within specs, and it's extremely close to even the 6.5 digit resolution of the Keithley. And I mean, we can dial it up. We're actually right on the outside of the range, so we'll have to range up on the Keithley, and then the Fluke will actually drop down. But I mean, we can go all the way up to the that's as much as my voltage reference can put out, and I mean, they're so close it's not even funny. We got a little bit of movement on the Fluke, but the Keithley's coming back. I do find that the Keithley tends to take a little bit longer to kind of settle, but I believe that that just has to do with that it's an older meter and it's just not as stable as the newer multimeters are. But I just figured that I would kind of give y'all a little view about what it looked like to have these things. That's the negative range. To compare a calibrated multimeter against just the regular one that you kind of buy off the shelf. I'm not even sure how old this 87.5 is. I bought it used and just compared it to every known reference that I had, and that's kind of how I built up confidence in it. But now, comparing it to the Keithley, it just is amazing. Alright guys, well, I'll see y'all later.